morning, everyone. Thank you for sticking around through the last day of Google Next. And today we're going to be talking about how you can take your enterprise network and extend it out into the cloud, various ways of doing that, talking about reliability of those mechanisms, and talking about many use cases on how you would do that. So let's start off. So you've all seen this picture, or a picture much like it. And this is the Google backbone and the network that you can connect to. So one of the things we like to emphasize here is that when you make connections to your VPC in cloud, you really are connecting to this infrastructure. So if you think about the kind of connections we're going to be talking about today, which are connections from your enterprise into cloud, it's also connections into this backbone, and it's a way to leverage that backbone. So there's a number of ways you can connect to Google. I'm going to talk briefly about two methods that I'm not going to talk in the rest of the deck about. One of them is direct peering, and the other one is carrier peering. For customers that need to connect to the Google public infrastructure, and what I mean by the Google public infrastructure, that's our ASN 15169 and all of the public Google services. That's Search, that's G Suite, that's YouTube, and all the rest of it. The way you can connect to us is either using direct peering or carrier peering. Direct peering is where you meet us in one of our peering locations, and there are roughly about 100 all over the world. And you place a router there and you peer with us using BGP. You need to meet our peering requirements. And for many customers, that's very difficult. So we have another product called carrier peering. And that's when you work with one of our service provider partners, and there's a list on our website of them, and allow them to peer on your behalf with us. A lot of customers use this. Some use it for G Suite connectivity, others because they want real low latency and fast access to YouTube. I'm kidding. The other methods for connecting are VPN, which we're going to talk about today, which is a way of using a cryptographically secure method of connecting over the internet to GCP networks, your VPC and GCP. And then finally, dedicated and partner interconnect. Dedicated and partner interconnect very much closely match the direct peering and carrier peering solutions. With dedicated interconnect, you meet us in one of our POPs. And with Partner Interconnect, you meet with one of our carriers, which meets in one of our pods. And I'll go into details about both of those. So which one do I use? This is a flow chart that kind of tries to help you make those decisions. By the way, a similar version of this flow chart is available on the cloud.google.com/interconnect site. So for instance, if you're using G Suite, it sort of moves you to direct peering or carrier peering. If you don't need a 10 gig pipe, it tells you maybe you want to use partner interconnect versus dedicated interconnect. If you can't meet us at one of our POPs, what do? You do cloud VPN or the partner interconnect solution. And we'll get into all the details about how all this stuff works promptly. So the first thing we'd like to talk about is how you use IPsec. IPsec is a low-cost, reasonable bandwidth solution into GCP. So roughly, depending on how you connect to us, if you're connecting us over a peering link, you can get up to 3 gig per tunnel. Otherwise, it's about 1.5 gig large packet per tunnel. And if we go through this diagram, I want to point out a couple things. First of all, if you notice, there are 2 VPN tunnels here, and they're connecting, using BGP to a cloud router. You don't have to use BGP. You can use static routing, but we recommend that you use dynamic routing. It's less error prone. It's easier to manage. But one of the things is that you notice those BGP sessions go to the cloud router. The cloud router is not a traditional router. All it is the BGP control plane. And if you went to an earlier talk that discussed Andromeda and the underpinnings of our network, you'll understand that what the cloud router is doing is taking routes and programming our underlying SDN fabric. And what it does is it programs routes into the VMs in your VPC, so those VMs know how to get off of your network. And what they have is that they have a default route to the VPN gateway, which is managing encryption and forwarding that traffic onto your on-premise network. What that means is that, first of all, the cloud router can support up to 128 BGP sessions, but it obviously can't support 128 VPNs going through it because, packets per second would kind of overwhelm it, right? So rather than worrying about that, we program these routes directly into the VMs, and all you are then is limited by the performance of the VPN gateway and each individual tunnel, which is about 1.5 gig. But you can eCMP that, and we have customers that are doing 20 gig of IPsec traffic between their VPC and an on-premise network. So it's a cool, very scalable solution. It offers an SLA, and it does have some drawbacks in that it's going over the public internet. So you're beholding to the latencies and jitter of a public internet connection. So many customers have used this to start out with, but eventually they move on to our other interconnect solutions, which are dedicated interconnect and partner interconnect. So dedicated interconnect, as I said, it's a 10 gig solution. In other words, all the connections to Google with dedicated interconnect are supported at 10 gig per connection. We support lag groups of up to 8, so up to about 80 gig. And then the partner interconnect solution, which will give you subrate interfaces starting at 50 megabits through many partners, which I'll cover in just a second. So let's talk a little bit about the locations around the dedicated interconnect solution. First of all, to connect to us, you need to meet us in one of our co-location facilities. And I'll put a list of the co-location facilities up in just a second. You are placing a peering router in that facility, and you're connecting to us using cross connects to our peering edge. And I distinctly say a peering edge because it's not a router, it's just an edge. It's a 10 gig port you plug in, and using our Espresso control plane allows us to package up your packets and send them on to your VPC. By the way, if you don't know anything about Espresso, there's a great paper on Espresso that explains how we do peering on our edge. Very interesting, not just from an academic standpoint, but just on how you build SDN fabrics. So to use dedicated interconnect, router in one of our peering locations and a cross connect to our peering edge. A little bit on requirements. So first of all, it's 10 base LR. So just a comment, we've have customers that have come out with other methods of connecting to us, and those don't work. We also support we require LACP. The benefit of LACP is as you want to grow that infrastructure, you can do it in a seamless way by adding 10 gig connections and growing that lag bundle as you need to. So for customers that have very large data rate requirements or are thinking they're going to have very large data rate requirements, it's really important for LACP to be there. Support of 802.1q VLANs, which is most, if not all routers support that. eBGP with multi-hop is also required. And finally, IPv4 link local addresses. So all those are the requirements that you need for a dedicated interconnect solution. As part of the process, you'd go into the cloud console, you'd get an LOA, you hand it over to your data center provider, whoever that is, and they would make that connection. There's a very hold your hand approach on setting up these connections. So after you get the LOA, there's instructions in the email of what you do next and take you step by step through the process of setting up that connection. So we find it, for the most part, to be very non-error prone, leads you through the whole process, and we've had very, very few escalations from customers having a problem through that process. So we try to hold your hand if you're using this method. As far as interconnect locations, this is what we have today across the globe. So in North America, a couple locations in Canada and a host of locations throughout the United States. One of the comments I will make is that, and I don't have an overlay of our data center fabric here, but when you may be concerned about latency to VM workloads, and if you're concerned about latency to VM workloads, you want to be extremely close to those VM workloads. So for instance, in our Ashburn facility, that's the one that's marked as Washington, D.C., you're roughly about, roughly around a millisecond away from a VM. Same thing with our Los Angeles facility, same thing with Frankfurt, London, and a few others, Tokyo, and a few others around the globe. If you're really concerned about latency, for instance, if you're doing a lift and shift workload where you have to leave some of it in your data center, so let's say you have a very large DB2 in-memory database that you need to leave in your data center, you might want to think about those facilities because you can take that infrastructure and deploy it in that facility and still have low latency access to your VM workloads. So just something to think about when you go around selecting a location to connect to us. One thing I will say about this list of locations, it's a evolving list of locations. So if you don't see it up there, it's probably going to be up there in about another couple months or another half a year, etc. So we're slowly rolling out locations that support dedicated interconnect over the next year. So there'll be a number of additional locations there. So now let's talk a little bit about partner. So the big difference between dedicated and partner is that you're not meeting us in one of our co-location facilities. We have a number of partners that actually have connections in our co-location facilities and can provide you a layer 2 connection into that location. So that means that you're in your facility and you're using one of those partners to connect to us. There are different kinds of partners that can connect to you, help you connect. So let's talk a little bit about them. They're wave partners. Wave partners are providing you a physical optical cable from your location to a Google location. In that use case, you're actually using the dedicated product, but you're using it like if it was an extended, the optical fiber was like an extended cross connect. So you would hand your LOA to your wave partner, and they would figure out where they're meeting us or what you tell them where you want to meet that fiber, and they would hand it over to whoever's providing the patch panel in that location. So there are a number of customers that use that because they want the bandwidth and the connections that dedicated offers, but they can't meet us in one of our co-location facilities, so they use a wave service. The benefit of this is that you don't have to place equipment in the co-location facility. Another type of partner is what we call a layer 2 partner. They're either known by EVPN or a pseudo-wire partner. And what they're doing is all they provide you is a physical connection that then you can do a layer 3 VLAN over that physical connection. So there are a number of partners, and if you go to our website, we actually categorize partners that do layer 2 or layer 3 connectivity. But those partners are giving you the ability to manage the VLANs on your equipment on premise. And then finally, there are layer 3 partners. Our layer 3 partner, MPLS VPN is a typical way of talking about them. They're typically doing BGP on your behalf to us, and then they're doing BGP to you as well. So they're managing how you can connect to us. Typically, you're connecting with an MPLS backbone, and you're telling them, can you please extend my MPLS backbone to the cloud? So for those of you that have an MPLS partner, this is a great way to do it. So if you were at a session yesterday, both AT&T with their product called NetBond and Verizon with their product SCI were discussing how to do this layer 3 type of connection. So what are some of the other differences of partner and dedicated? I think the biggest difference between partner and dedicated is that you can get sub-rate interfaces with partner. So for instance, if you're a retail establishment with many stores all over the nation, you don't need a 10 gig connection per store. You may want a sub-rate interface per store. You probably have an MPLS provider. They're giving you, 100 megabit MPLS link to cloud for each one of those stores. So that's something you can get with partner, but you can't get with a dedicated solution. Some of the other big differences, because you're only paying for what you need, it can be less expensive. It can be less expensive with partner. You don't have to pay for the rack costs in a co-location location. You don't have to think about the amortized costs of the router that you're putting in that location, etc. So sometimes partner can be a more cost-effective solution. And as well with partner, you can, from start to finish, especially if you already have a partner and connections to that partner, can be extremely fast, order of minutes. Whereas if you're using dedicated, unless you have the gear placed, you have the rack bought, you have all of those contracts in place with the co-location facility, that can take a little bit longer. Typically, dedicated takes order a week, versus partner can take order minutes, depending on the partner connection that you have. One other difference between partner and dedicated is with dedicated, you own the 10 gig circuit. It's yours. You can do anything you want with it. You land VLANs in multiple projects. And with a partner connection, that 10 gig circuit is shared amongst a number of other companies. We have provisions in place so that that circuit is not overloaded. So we force our partners to augment those circuits as they start reaching capacity levels. So let's talk a little bit about the partners we have. We launched the partner solution about 6 to 7 weeks ago, and we launched it with this set of partners. Since then, we've added a number of additional partners, and we continue. Actually, there were a number of partners that would have been on this list, except they didn't get the signature on the contract in time, so they were left off the list because I had to do my slides at some point, right? So this list continues to grow. If you don't see your favorite partner here, come and talk to me. We can get them on the list. And by the way, if you want to see a full list of the partners, there's a URL for that. In addition, at that URL, it'll give you additional details about the partner, like how do you contact them, what services they offer, things like that. And I will say one thing, with this suite of partners, this also extends the reach of the number of data centers that we support. So if you look at many of these partners, you think, oh, and you go to this URL, you'll see that they only meet us in certain locations. But for instance, if you go to, what's a good one? If you go to a partner like a Megaport, they have connectivity in a large number of facilities across the globe. So if you can't be in one of our locations, many of these partners can help you be in one of those locations because they have a very diverse set of connectivity. An example, I just said Megaport, another Equinix, for instance, has their own backbone that connects all their data centers together. So if you're in one of their data centers, they can connect you to cloud. So many of these partners give you that last mile, that extra data center connectivity back into a cloud offering like GCP's. So let's talk a little bit about the details of both partner and dedicated interconnect. I use a lot of the dedicated interconnect diagrams here, but they also work for the partner interconnect solution. So on your peering router, whether it be on-premise or in one of our data center, one of our co-location facilities, you're exposing a link local address to the cloud router. We're exchanging BGP across that link, and we're extending your network into your VPC, cloud VPC. That means that we take routes from your network and we program those routes on the VMs, and we take those VMs and expose those routes to your data center as well. So fully meshed, it just looks like you extended your data center into another room, but what you've done is you've extended to the cloud, and in addition, you've extended to the globe, as I'll go through in just a second. So we have a feature in the cloud router called global routing. And what global routing does is it takes your VPC subnets that are in other regions and advertise them over a BGP connection back onto your data center. So if you see this diagram, we have two connections, one in one region, one in another region. Both of those connections are advertising all the routes that you have on your VPC. The reason you might want to do these in 2 regions is because you may have a connection in Tokyo and a connection in Chicago. But what's happening is you're getting all your routes to all your VPC over those 2 links. So you may have a VM running on a data center in London, and you still have access to it from your on-prem, but you don't have a connection in London. And the benefit is that you're going over our backbone to get to those VMs. So as I said when I started this presentation, that large network, you get access to that large network with 1 connection. And this is a good example of that. So in this use case, we're connecting to 1 region and to 1 cloud router, but because of global routing, we're advertising the routes to other regions over that 1 link. So in this case, let's say you're connected in Chicago, you still have access to our data center in Tokyo, you have access to our data center in London, you have access to our data center in Frankfurt or Mumbai or wherever those regions are set up. So it's a very cost-effective way of extending the reach of your data center network to a global footprint. Now, I will caution, there are 2 charges when you do this. There's egress charges from your local region. So for instance, if you're connected in Chicago, there'll be an egress charge from a local region to Chicago out. And if you wanted to connect to Tokyo, you're going to pay a Tokyo to a local US region egress charges as well. But again, it's cheaper than stringing a long, long connection to a data center halfway around the world. So let's talk about how you connect multiple projects. In the dedicated use case, you'd have multiple VLANs over that same 10 gig connection. In the partner use case, you just have multiple VLANs. You don't care how they route or who they route over. But what you're doing now is with multiple projects, you have complete separation between those 2 projects. You have network assets in those 2 projects. They don't know one from one other. Even if you're using the dedicated single 10 gig connection, they can have overlapping address space. They can do all that kind of stuff. So this is one way of connecting multiple projects. It is not the recommended way, though some people need to do it this way. The recommended way is to use something called shared VPC. How many of you know what shared VPC is? Oh, we're doing our job. What shared VPC allows you to do is think of each individual project the way you would think about resources that you have in your data center. So when you have a developer come to you and say, I need VM resources, I need network access, I have this special project I'm working on, you don't care what the project is, but you need to give them network access, that's what shared VPC is doing. It lets you say, I control the network resources, I control the firewall rules, and I give you access based on what your needs are. Do you need, access back to your data center, database? Probably not, so you firewall that stuff off. The shared VPC allows you to control who gets access to the network, what firewall rules are placed on those individual projects. So this is a way of using your network assets in the most efficient way possible. So I have customers come to me and say, I need 100 VLANs. Well, why do you need 100 VLANs? Well, I have 100 projects I need to connect back to my data center. What you really think, if you think about that, what they really want to do is they want to use shared VPC. Because they don't need 100 VLANs, they want to give networking to 100 projects. And this is an efficient way, I got the scaling numbers wrong, but this is an efficient way of giving access to a number of projects using one VLAN resource. So you can put in a high capacity VLAN and give access to a number of projects and control the way they access your data center. And by the way, there was a great talk on this that you should listen to because it's already happened. So it'll be available on YouTube in a week or so. So let's talk about connecting to multiple clouds. Because I don't care who you are, you most likely have some resources that are running in another cloud. And how do you do that? Well, there are a couple methods of doing that. What I'm showing here is showing how you would use a router that you have in a co-location facility or on-premise, and you take two legs, stick one in one cloud service provider and stick the other one in GCP. You'd get route information from both of those, and now you'd have a connection between those resources into cloud infrastructures. The one thing you have to remember is you could have an issue with overlapping IPs, so you need to be careful of that, in that you can't have overlapping IPs without having a NAT device on premise. Now you say, wow, that's a real pain. I have to go stick a router in some point of presence someplace and connect this and manage all that. That's a real over-the-top amount of effort. There are companies, and I'll mention Megaport here because their product is actually in production right now, and there's another large infrastructure provider that is actually doing something very similar. What they've done is they've virtualized the routing function in those POPs, and they give you APIs or user interface that allow you to point and click and connect two CSPs together. So a very easy to use, very cloud-like approach to connecting two cloud service providers together. So the Megaport solution is called the Megaport's Cloud Router. It's on their website. You can trial it. It has a pretty nice user interface to walk through. They have a booth on site too as well. The other, and I can't speak for the other company that's doing this because I'm not authorized to, but I'm sure you'll see press when they make their solution available. So that's how you'd connect two cloud service providers together. There's actually another method of doing this as well. Because one thing you can do is just connect them using an IPsec connection. So the Cloud VPN solution, there are a number of guides that help you connect to common cloud service provider infrastructure. And you can make an IPsec connection. You can have multiple links. You can do ECMP over those multiple links and get pretty reasonable connectivity between GCP and another cloud service provider. Google as a whole has very good, I would say, rich connectivity pairing between our CSP competitors. So you can be assured that those links are going over adequate connectivity. So let's talk a little bit about high availability, because your connections from your data center to cloud really need to have some level of reliability when you can connect. So to do we offer two SLA levels with the dedicated and partner interconnect solutions. Again, it doesn't matter which one you're using, you have to do more or less exactly the same thing. You have to meet us in one metro with two links to get a 3 nines of availability. What I mean by a metro is, if you remember that map with all the points of presence, a metro is one of those points of presence. So you need to meet us in one of those points of presence with two connections. If you're using dedicated, that means you have two 10 gig links. If you're using a partner solution, that means you have two VLANs connected in that metro. That will give you a 3 nines of SLA. We also recommend that you use Graceful Restart on the cloud router, and I'll go into some details of that in just a bit. To get to 4 nines of availability, you need to meet us in two metros with two connections in each one of those metros. So let's say you're meeting us in Chicago, you also need to meet us in Dallas or Los Angeles or somewhere else to get the 4 nines of availability. And again, I stress that this is two metros because our SLAs are metro bound and they're not 4 connections anywhere you want. So this is a way of getting a 4 nines of SLA into the Google infrastructure. In addition, with the 4 nines of SLA, you need to implement global routing on the cloud router so that I can advertise all the routes over those links. So if one link fails, I can use the other link to connect to GCP. So we talked about IPsec as being a method of connecting back into the Google infrastructure as a way to start out. You know, you're not sure you want to do this, or you don't know what the volume of connectivity is, or you're just in a proof of concept. So you can start with an IPsec connection to connect to us. The default, by the way, I recommend using dynamic routing. This particular use case is all going to be using dynamic routing. And in this case, you're advertising all your BGP routes using a default med of 100. But now you want to move over to a dedicated or partner interconnect. So you've set up 2 VLANs, or 2 dedicated 10 gig links with VLANs over them, and you've set a default med priority of 1,000. What that means is that your IPsec connection is the preferred path to and from your data center. And the secondary path is that dedicated interconnect. And you can go through the CLI, or you can use the GUI, and you can change the med values, and traffic immediately swings over to the preferred method that you've chosen. So in this use case, you've moved all your traffic over the VPN, and you've moved it onto the new dedicated interconnect that you've set up. One of the benefits here is also you can still maintain that IPsec connectivity. So if you have a problem with the dedicated interconnect, it'll all swing back to your VPNs as well. So a nice, very simple way of doing both a transition and a failover mechanism to the VPN tunnels. So we talked a little bit about Graceful Restart as a way to minimize downtime. Cloud Router is a software component. We update it all the time. Like once a week, we're doing some change to it, updating that software. And you will have an issue because your BGP session goes down. BGP session goes down, you lose connectivity, you withdraw routes, do all that kind of stuff. So Graceful Restart is a way of not withdrawing routes when you have a BGP session down. And it gives you the ability to say, wait for a little bit of time before you withdraw routes. That BGP session might be coming back up, and I want to be assured that I still have connectivity. Our recommendation is to, and by the way, there's a lot of documentation on this on our website, as well as there are the sample CLIs for both Juniper and Cisco gear on how you set all of this up to take advantage of our recommended configuration. And the recommendation is to just don't turn on Graceful Restart, but do not use any of the modifiers for Graceful Restart. And what that will do is it will give you a connection that has about 61 seconds of failover time. That means if your BGP session went down because of an actual, let's say, a physical cut in cables or something like that, it'll take about 61 seconds for that BGP that traffic to fail over to the secondary link. We're going to improve the timing on this through implementing some other methods that you find in common off-the-shelf routers, and those of you know things like BFD, and we'll improve this failover time over time. So, but this today is the default recommended configuration, and this will give you a 61-second failover time. We also talked a lot about global routing, and I want to go a little bit under the covers on how global routing works and what you get out of global routing. So when you set up global routing, that means all the subnets are advertised over your BGP session. If you have multiple connections to GCP, you want to make sure that you're using the optimal path. So for instance, if you have a connection in Tokyo and one in Chicago, you don't want your data center in Tokyo to go over your backbone and come into Chicago. So what we do is on the advertisement, we modify the meds of the remote subnets by adding the RTT value of those remote subnets. So your subnets in Tokyo will have a very low med value in Tokyo, and they'll have a very high med value in Chicago. So traffic from Tokyo will prefer your Tokyo connections, and traffic from Chicago will prefer the Chicago connection. The one comment I will make is that you should make sure that the default med values are far enough apart so you don't run into an issue. For instance, if you were to default of 100, and let's say you're doing Chicago and New York, you may have some interesting, if you want to prefer your Chicago connection all the time, add 1,000 to the default med value that you're advertising out of New York so that you don't get into an issue where the round trip time is longer than the default net value that you're advertising. So that'll always prefer one connection over the other if you add a very large value to the default net value. And all of these things are available in the Cloud Router CLI as well as in the GUI to be able to set all of that up. Monitoring. So now you have all this great infrastructure set up and everything is working great. How do you monitor this infrastructure? There are two distinct ways of monitoring this infrastructure. One of them is you can go into the Cloud Console and we will give you things like link utilization, drop data, etc. And those are time series values, so you can select whether you want to see the last hour or the last day or the last week, etc. So pretty nice, rich user interface around all the monitoring data, and you can get that right out of the Cloud Console in the section around the object you're trying to monitor. So you can go into the interconnect and monitor that interconnect. You can, with partner, you can go to the VLAN and monitor that VLAN. In addition to that, we also support stack driver monitoring. So for instance, if you want to put alerts on, if you're using dedicated interconnect and you want to put alerts on the value, the dB value associated with the connection, what's the light levels on a particular connection, and if they drop below a certain level, you want to be alerted, you can do all of that in Stackdriver. If you want to do an alert that says, my link utilization is up over 75%, you can do that into Stackdriver and get those alerts so that you know what's going on. While we're talking about alerts, let me mention one other thing. We take down infrastructure from time to time, mainly for maintenance. We're putting a new line card, we're readdressing some ports, stuff like that. All of that information is also available in the Cloud Console. You can get alerts on when we do maintenance outages so that you're aware your BGP sessions go down. It's not an issue. You know that that's a maintenance window. You've done an outage. We try to notify you within a reasonable amount of time so that if you want to, for instance, swing your traffic away from one link to another because of that maintenance event, you can do that. So all of that is available in the console. All of this is documented as well. So I do recommend reading the documentation. I'm always surprised at how many customers always do a Google search before they actually go read the documentation, and the Google search just takes them back to the documentation. So a good way to figure out how these products work, there's not a lot of documentation, there's enough. It's not a long read. Take advantage of the time and effort our doc people go into putting out a really stellar amount of documentation that helps you understand how all this stuff works. So finally, let's talk a little bit about how much all of this stuff costs. So VPN, we charge 5 cents per tunnel hour. That works out to, I believe, $32 a month for a VPN tunnel. With dedicated interconnect, it's $1,700 for a 10 gig circuit per month. And then for every VLAN that you put on that 10 gig circuit, it's a charge of $72. So for if you're thinking about redundancy, 3 nines would mean 2 connections, so $3,400 a month. And then, of course, with a 4 nines of redundancy, you're doubling that again for $6,800 a month. The other, on the partner interconnect, it's a sliding scale. It starts about $39 a month for a 50 megabit attachment and goes all the way up to $1,700 for a 10 gig attachment. Our peering solutions are free. Both carrier, our direct peering solution is free. Our carrier peering solution is free. Of course, you may have to be paying some money to whoever the carrier is that's helping you peer. But we have a settlement-free peering solution. Of course, you do pay egress costs on those links, and those egress costs are our internet egress cost rate. So speaking of egress on VPN, it's just like an internet connection. So depending on how you're connecting to us and where you're connecting to us, that runs from about 8 cents a gig all the way to 23 cents a gig. And the higher end of the scale is for places like Australia and South America, where it costs us a lot more to provide transit in those locations. For dedicated and partner interconnect in North America, we charge 2 cents per gig. If you're interested in other locales, please go to the website, and all that pricing is available there as well. For carrier and direct peering, we do give a discount on our standard internet rate of egress, and in North America, that's 5 cents per gig for both carrier and dedicated peering and direct peering. So we gave a lot of sessions at this conference, and this is the list of all the sessions that are here. The reason I'm putting this up is all these sessions will be available on YouTube. So if you miss something that's of crucial interest to you, like I think there's actually one happening at exactly the same time. So if you were worrying about enterprise-ready networking for GKE, which is happening at exactly the same time slot, go to YouTube and you'll be able to get that presentation online. And finally, two final things. I don't know if you guys have seen this. We have a wonderful poster that's it's an online giveaway. In other words, you go to this site and either you can download it yourself or you can have it mailed to you. But this is a poster that shows our network, all our POP locations, all our data center locations, all our undersea cables, all our terrestrial cabling, etc., all in one beautiful picture. So it's kind of a cool, put it up on your wall and people will ask you, what's that map of the world all about? Finally, in closing, I'd like, if you could, please give feedback on this session. You'll find feedback in the next 18 application under, let's see if I get this right, under notifications, and they'll have all the sessions that you've attended, and you can give feedback there. It's kind of hard to find, but we really appreciate any feedback you can give.